For our do now, we're asked to take these two equations and solve for y in terms of x. That also means to take the equation and put it into slope-intercept form, just another way of stating that. So we're going to isolate our y. Let's subtract 4x from both sides. 2y equals negative 4x minus 8. We'll divide both sides by 2. So we get y equals negative 2x minus 4. Okay. On b, we'll subtract x from both sides. 1/2 y equals negative x plus 3. Now we have to eliminate that fractional coefficient. Remember, to eliminate the fractional coefficient, we're going to multiply by the reciprocal, which is 2 to both sides. So we have y equals negative 2x plus 6. The second part of the do now, we're asked, what do you notice about the slopes? Well, the slopes are right here. They're both negative 2. They are the same. Here on page 26 in our booklet, we're going to take a look at parallel and perpendicular lines. We're given two sets of equations, and we're going to graph them both on Desmos, and we're going to look at the first set individually, the second set, and then look at them together. Here we are on Desmos. I graphed the first two lines in our set, and I'm going to graph the last one with you because I had some questions about how do you do a fraction on Desmos. So our fraction is 1/2, so I'm going to type 1, then I'm going to go and I'm going to use my little dash button, slash button, whatever you call it, and put that there, and then it brings us to the denominator. I go to 2, and then I'm just going to arrow over so I'm no longer in the denominator. Now I can put my x plus 1. Okay, so if we look there, we can see these lines. We've got red, blue, and green. You can change the colors there if you want. And we can see that they go on and on forever, but they will never ever touch. And I can, zoom out and see it looks like they will never touch. They continue on forever. If I click the home button, I get centered again at the origin. So we answer for number 2. What kind of lines are in set number 1? Well, they are parallel. On Desmos, I graphed our second set of equations we can see here. It's a little busy, so if I want to hide our other set, I just click there and the lines just temporarily disappear. Now I get a clear picture. I can see we've got 3 negative slopes. They also are never going to touch, so we would say the second set is parallel. Like I said, the lines that are in set 2 are parallel. And we want to look, what do the equations in set number 1 and the equations in set number 2 have in common? So looking at each set individually. What does set number 1 have in common? Well, something I notice is they all have the exact same slope. If I look at set number 2, they also all have the exact same slope. Okay, so what do they have in common? They have the same slope. What do they have that's different? What's making them a unique line and not just a repetition of the same line is that different y-intercept. They all have different y-intercepts. And on C, y equals negative 2x, our y-intercept is really 0, but we don't write the plus 0 because it just simplifies to negative 2x. So they have the same slope, but different y-intercepts or different starting points on the y-axis. So if two lines have the same slope, but different y-intercepts, why don't we put our little variable abbreviations in there for our notes as well, then the lines are parallel. Okay? Now we're going to go back to Desmos and we're going to look at the relationship between the two sets of lines together and see if we can see any sort of connection. Here we are back on Desmos. Now I'm just going to bring back that first set of equations. So I just click on them again and they pop up. I can see them. Maybe I'll zoom out a little bit so I can see. And we want to know what's the relationship between these two sets. Well, they're definitely not parallel to each other because they're intersecting. But what does that mean? What do we call that relationship? This is usually when students say perpendicular. I'm like, yes, exactly, they are perpendicular. What does that mean? And then students usually say, they intersect. I say, okay, but do we call all lines that intersect perpendicular? No, we don't. So what makes it special that these lines are perpendicular? And it has to do with the way they intersect. That each one of these lines, when a line from the first set intersects with a line from the second set, they create a 90-degree angle. And that's what our definition of perpendicular is. Two lines that intersect to form a 90-degree angle, or a right angle. So like we said, what is the relationship between the lines in set 1 and set 2? We say they are perpendicular. And let's put in the detail. They intersect to form or at a 90-degree angle. So we saw that visually in the graph. Now we want to take a look to the equations. What in the equations, what relationship is there that shows us these lines are going to be perpendicular? And it has to do with the slope. So let's take a look at the slopes in set 1. So in set 1, our slope is 1/2. In set 2, our slope is -2. So we want to look, what's the relationship there? And what tends to happen is students tend to think of they're kind of like the opposite. But it's more than just the opposite. Because we have this fraction that's flipped, right? 1/2 flipped is going to make it a 2, but then it's also negated. We also see that sign changed. And we have a special vocabulary word for these. We say that these slopes, 1/2 and -2, are negative reciprocals. So that's like the flip of the fraction, right? Reciprocal, we see that flip. We saw it in our do now. When we were eliminating the fractional coefficient, we multiplied by the reciprocal, right? The reciprocal of 1/2 was 2, right? The flip. And then the negative, right? We're switching the sign. That's what a negative reciprocal is. Okay? So what is the relationship between the slopes? The slopes are negative reciprocals of each other. And something we notice with numbers that are negative reciprocals, and I'm going to use our examples of 1/2 and -2, is that when you multiply them, their product is -1. And that's a fun little fact there. Okay, so that's a way to check. Multiply the slopes. If their products are -1, then they are negative reciprocals. If the product of the slopes of two lines is equal to -1, then the lines are perpendicular. Okay. If the two lines are perpendicular, then the slopes are negative reciprocals. And we're going to take a moment just to go and practice specifically identifying negative reciprocals. Here we're just going to practice finding the negative reciprocal of a given slope. So if we have a slope of 3/4, the negative reciprocal of that, we're going to flip it and change the sign. So it would be -4/3. Those are now negative reciprocals. -1/3, we're going to flip. So that makes it 3/1, right? and then we're going to negate that. So we have to make it positive. We change the sign. The negative reciprocal of positive 5 would be 1/5. Now change the sign. Negative 1/5. Negative reciprocal of negative 7/6. Flip it. Change the sign. So you make it positive. The negative reciprocal of 1, right? 1 is 1/1. So when you flip it, it's still 1/1 or 1. And now change the sign. So the negative reciprocal of 1 is negative 1. The negative reciprocal of negative 1 is positive 1. The negative reciprocal of 0, now this one we kind of want to visualize, right? A line with a slope of 0 is a horizontal line. So a line that would make a 90-degree angle with that would have to be vertical, which has an undefined slope. Right? So if we make an example of a slope of 0, that could be like, for example, 0/4. Flip that. Negative 4/0, you can't divide by 0, so it's undefined. The negative reciprocal of an undefined slope, right? What's going to intersect at a 90-degree angle with a vertical line? It would have to be a horizontal line, so slope of 0. Back on page 26, we're going to do number 10, create two equations of two parallel and two perpendicular lines, and then you can check your work on Desmos. So equation number 1, we're just going to make one up. I'm going to say, let's do, I don't know, y equals 8x minus 7. So parallel lines, same slope. Okay, I have to memorize that. Parallel lines have the same slope. So to have an equation of a line that's parallel to 8x minus 7, it has to have a slope of 8. It also has to have a different y-intercept. So we want that to be any number that is not negative 7. Like, let's say, positive 6. Those should be parallel. Now let's check on Desmos. I graphed our first equation. Let's throw our second equation up there. Boom, they are parallel. Now working with our perpendicular lines, again, we're going to make up an equation. I'm going to say, let's do y equals 3/4 x plus 2. Okay. Parallel lines, I know their slopes are negative reciprocals. So I want to think about that slope of 3/4. What's going to be the negative reciprocal of 3/4? We'll have to flip it. That makes it 4/3, and then I have to negate it. I have to change the sign. So my equation is going to have y equals negative 4/3 x, and then I choose the y-intercept. And with the perpendicular lines, it doesn't have to be a different y-intercept. If you have the same y-intercept, that's just going to state that's where the two lines intersect, would be at that y-intercept on the y-axis, but it could really be any y-intercept. Okay, so let's go check on Desmos. Here we are in Desmos. We have our first equation graphed. Now let's graph our second, and then boom, we see that nice intersection point right there where they're intersecting at 90 degrees, showing that perpendicular relation. On page 27, number 1, we're looking at 3 sets of equations. We're going to determine if the pairs are parallel, perpendicular, or neither. And we'll explain. Now, parallel, perpendicular, neither, it's all about the slope. So we have to be able to see the slope. In order to see the slope, we have to have the equations in slope-intercept form. So down here, y equals negative 2x plus 3, I can see the slope is negative 2. But that equation up there, I don't know. So I got to go over here, put it into slope-intercept form. Some of you might say, oh, well, I can kind of see it without it. No, prove it, right? So we see this one also has a slope of negative 2, which would mean they are parallel, and we've stated it. They're parallel. They have that same slope. Okay. So then B, well, that's just kind of out of order. Y equals 4x minus 7. I can see that slope is 4. Y equals negative 1/4 x plus 10, I can see the slope is negative 1/4. Those slopes are negative reciprocals, so they are perpendicular. And I'm going to state that they have those negative reciprocal slopes. Okay. C, we've got to get both equations in slope-intercept form, so let's start working on that. We'll subtract 2x from both sides. 2y equals negative 2x plus 10. Divide both sides by 2. So we get y equals negative x plus 10. I can see that that slope is negative 1. And then let's get that 5y minus 3x equals 20. Add 3x. 5y equals 3x plus 20. Divide by 5. We get y equals 3/5 x plus 4. So that one has that slope of 3/5. And we're going to say neither. And really our reasoning is there's no relationship within the slope. Here, number 2, really good question. Determine the equation of a line that is parallel to y equals x minus 1 and goes through the point 4, 5. And then it says graph both on Desmos to check. Blah. Okay, so we're going to write a new equation of a line that's parallel to that given one. As soon as I see the word parallel in my head, automatically I'm screaming same slope. Okay, and I think what helps us with this problem not only is our skills from yesterday, but also in our division of our work. I'm going to separate it into 2 parts. So my given information and then my new parallel equation, and I know I need that same slope. So I'm just reminding myself of that key information. So what information are we given? We're given that y equals x minus 1. From this, I know the slope is 1. And I know for my parallel line, I'm going to have to use the same slope. Now our new parallel equation is going to be in slope-intercept form. And we've got all those variables, right? We need an x, we need a y, we need an m, we need a b. Okay, so let's look to see what we've got. What information is given to us? Well, we know that new line is going to go through the point 4, 5. So we've got an x, we've got a y right here, 4, 5. It's for that new line. This is sort of that given or that old parallel line. We know we need that same slope, so our slope has to be 1. What we don't have any information about is our b value. So that's going to be our variable we're going to solve for. So let's substitute into y equals mx plus b. We'll solve for b, and then we'll write the new equation. So let's see, y is 5, our m is 1, our x is 4, plus b. Notice how we left the b a variable. So we've got 5 equals 4 plus b. We're going to subtract 4 from both sides. So we get 1 is equal to b. Okay. Now we're going to write that new equation. And when we write that new equation, we're going to use our same slope, okay, and that sort of new b value, that new y-intercept. And then we substitute in y equals x plus 1. And there's our new equation. Number 3 is essentially the same question, except this time we're going to write an equation for a line that's perpendicular. So line that's perpendicular to y equals x minus 1 and goes through the point 4, 5. As soon as I see perpendicular, I'm thinking that our slopes are those negative reciprocals. So I have that memorized. Again, I'm going to separate my information into that given line, that old line, and then that new perpendicular line with that negative reciprocal slope. Okay. Our given line was y equals x minus 1. From that, I know the slope is 1. We're going to write a new line in y equals mx plus b form. For that, we're going to need an x, a y, an m, and a b. Because it's a perpendicular line, I know the slope is going to be that negative reciprocal. So I have to think, what's the negative reciprocal of 1? Well, it's negative 1. Do we have information on the new line about x and y? We do. It's right there. And the only reason we need that information about x and y is so we can solve for b, just like we were doing yesterday. So now we can substitute in 5 equals, that'll be negative 1 times 4 plus b. So 5 equals negative 4 plus b. We'll add 4 to both sides. 9 is equal to b. Now we're going to write that new equation. When we write that new equation, we're going to use our slope. That's going to be that new negative reciprocal slope, negative 1, and that new b value, right? We just got there. That new b value is 9. So we write our equation, y equals negative 1x plus 9, right? And we can just simplify that. Y equals negative x plus 9. And there's our equation. Your classwork on pages 28 and 29 are very similar to what we did together, so definitely use your notes as a guide. Then, if you'd like, you can check your work using Desmos. Today's math jokes for mathy folks. Why can you never trust a math teacher holding graph paper? Well, because they must be plotting something. All right, guys, have a good one.